I'm not just gonna write out all the steps. We're gonna kind of write out the steps while we're working through number 1, okay? But the first absolute thing that we have to do is we have to assume a 100-gram sample. We have to assume we have a 100-gram sample. If it is 100 grams and I tell you you have 20% of something, how many grams is that? 20, right? Do you guys see what we just did? We took the percent, we crossed out the percent, and we changed it to be grams. So we're basically saying that percent, we're going to convert those all. I'm sorry, I should not be saying the word convert. We're just going to change them to be grams. Percentages all change to grams. All right, so let's see what that looks like for our example 1. It says find the empirical formula of a compound who contains this much sodium, this much sulfur, and this much oxygen, right? So I have 32.38% sodium. So I'm going to say, okay, nope, it's grams. I scribble it out, and I'm writing a G for grams. And I'm just going to put sodium because you do want to kind of pay attention to which element you're doing along the way. All right? All right, so we have 32.38 grams of sodium. We have 22.65 grams of sulfur. So notice I didn't even put the percentage this time. And then we have 44.99 grams of oxygen. Second step. Once we have it all in grams, now we're going to convert grams into moles. So convert grams to moles. Now thinking back to what we just did in the warm-up, what's a simplified way to do that? It was the first part of our warm-up. What did we ultimately do? If I don't want to set up the dimensional analysis. We took our mass and did what? Exactly. We divide it by its molar mass. So we're going to take, so I'm just going to actually write that right here. Divide by molar mass. Okay? You're dividing by the molar mass for that element. All right, so let's look at what that looks like. So I have 32.38 grams of sodium. How familiar. All right, so we already did that one for the warm-up, right? So we're just going to divide it by its molar mass, 22.990. And our answer from our warm-up was 1.408 moles. Okay, all right, let's do the rest for these. So if I have 22.65 grams of sulfur, what number am I going to divide by? Perfect. 32.0, and I'm actually going to change that 66. Should be 066. 06. Is that what you guys got? Yeah? Okay, cool. All right. So the last one is our oxygen. So we're going to take our oxygen and we're going to divide that by its molar mass, which is 15.999. All right, cool. So we knocked out step number 2, convert grams to moles. Piece of cake. All right, so now we have moles. In an amazing world, we would just use those as our subscripts. So we would say sodium 1.408, sulfur 0.706, like as subscripts, right? But we know that in all the chemical formulas that we've seen, what are those subscripts? Are they ever decimals? No, they need to be whole numbers, right? So what we're going to do is step number 3. We're going to take all of our moles and we're going to divide it by the smallest. So divide mole answers by the smallest. So question, if we divide the smallest by the smallest, what number is that going to make? A 1, right? So that's really all we're doing. We're trying to get a ratio relating them all to one of them. That's really all that we're doing here. Okay, so we're going to divide the mole answers by the smallest. So you should get one of them being 1. This is an okay step to round. However, if you get a 0.5, you may not round that. Okay, so it's okay to round and just say except 0.5. And what I mean by 0.5, I probably should have just left it blank. Something 0.5, anything 0.3. All right, so we're going to do that. And then what we're going to do with all those answers, those numbers become subscripts. Okay, so let's go ahead and take care of that. So we have 1.408 for the first one, 0.706, 2.812. What is our smallest number out of these three? I agree. So I think you should circle this since it's in your notes, right? We're going to circle that so that we know that we picked out the smallest one. We're going to divide each of these by 0.706. Okay, so for now though, plug them in and make sure you're understanding what it'll look like on your calculator. So this one I got 1.99, so I'm going to round that up to 2. This one obviously is a 1. This one I got a 3.98, which is about 4. So we have a 2-1-4 ratio, so our answer is Na2SO4. Who is that compound? Sodium sulfate.